suppose f of x equals square root of x and g of x equals 2 raised to the power x. Okay? Then we can combine these. Now these are basic functions. How do you get the graph of the square root of x? How do you make a table for square root of x?
Square root of everything.
Again?
Take the square root of everything.
No. But in some circles you would, but not in this class. So it's not a bad answer, but we're not going to do that. I think I've said this. Maybe I'm manufacturing false news here. I talk about taking the graph of x squared and switching the columns. Did we do that? That sound familiar to anybody? Okay, some of you are shaking your head no. And there are enough competent people in here that I think some competent people, everybody's competent. If you're shaking your head no, I probably didn't. Okay? So we'll go back and do that because it's going to be important. But you don't need that to answer this question. Okay? It's one of your basic functions. And I'll probably ask you to graph it, because I probably haven't asked you to graph it. Okay, what's f of g of x? Well, first of all, what's f of 16? Okay, this f of x notation. Okay, something maybe we're a little shaky on, so let's.
Would it equal just the square root of 16?
Yeah.
4.
Okay, let me do this in another board. Okay, because this is something that often gives people trouble. Understanding just what that f of x means. So let's take, first of all, f of x equals square root of x. Okay? Now if I write f of 16, how does this differ from this?
You have a value for the x?
I'm sorry?
You have a value for x?
Well, yeah, where I had x, I have 16, right? So I've replaced x by 16. So you can think, okay, now x has been given the value 16, to put it in the words you use, okay? It's perfectly good and perfectly correct, okay? But what you see visually is that x has been replaced by 16, right? So what do you think I have to do with this x?
Replace it.
I have to replace it by 16, okay? If I've replaced x by 16, I want to write out this whole expression, then if f of x equals the square root of x, f of 16 has to equal the square root of 16, right? And some of you probably know the square root of 16 is more than 1 and less than 1,000, right? Can you narrow it down a little more? Yes. Everybody knows that. Okay? That makes sense? Okay? So let's see, what's f of 37? Well, you take this expression and you're writing it out, but now x is 37, right? So this is the square root of 37 equals you don't know. It's between 6 and 7, it's closer to 6. You would need your calculator to get a good decimal approximation. It's also an irrational number. Decimals just keep going with no repeating pattern. Okay? So you can't ever write it down in decimal form exactly. Okay? It's a little less than 6.1. I would say 6.07 or 6.08. If you got a calculator, you can prove me wrong. Okay? But that's what it probably is. But that's only an approximation. Even your calculator is going to give you at least 8 digits, right? And that doesn't mean that's the end. That's just as far as your calculator goes. Okay. What's f of a plus b? Well, that's, you've replaced x by a plus b, right? It's this. It's not this. Okay? I mean, what's the square root of 16 plus 9? What's 16 plus 9? 25, right? What's the square root of 25? 5. What's the square root of 16? 4. What's the square root of 9? 3. What's 4 and 3? 7. 7 isn't equal to 5, is it? So you can instantly use that example or any number of examples to prove to yourself that this is not the same as this. In other words, the square root doesn't distribute over addition. Now, since you're used to doing mathematics by habit, and since it looks like that ought to distribute, if you're used to distributive law, which you probably are, okay, it's real easy to accidentally write this down, right? That's what I mean by knowing the rules. There's no distributive law of square rooting over addition, okay? No such thing, because you can easily disprove it using 9 and 16, okay? So it equals this anyhow, okay? What's f of aardvark?
It equals the square root of aardvark.
The square root of aardvark, right? Okay? What's the square root, or what's f of g of x? I'm sorry?
Square root of g of x.
That's what I thought you said. A little noise in the hall. Deficient ears. Okay? The square root of g of x, right? Get the pattern? Whatever's in these parentheses for this function is what's here, right? And if there are a bunch of x's in this expression, then every x is replaced by whatever's in the parentheses, right? Now, go back to my example. F of x, the square root of x is g, and g of x you could write f of g of x equals the square root of g of x, which is the square root of 2 to the x, right? And this is a combination of the square root function and the 2 to the x function. Okay? Well, we can take our basic functions and form composites. Take any two basic functions, you should be able to write down the composite. Okay? And composites of our basic functions comprise the majority of the functions that you use in almost any profession. even engineering. Okay? Now, they also have sums and multiples of functions that are important, but they're a little easier to understand than composites. So this whole thing, by making composites of your basic functions, you get a whole new bunch of functions, which is why I want you to understand your basic functions, because this whole course builds on those basic functions. Okay? You know how to do the graphs and the tables, and you did pretty well with the tables. Okay? And there were a few little glitches with the tables, but I think we kind of cleared those up last time. People seem to be doing pretty well with that. Okay? And the reason, again, you don't use the x equals 1/2 when you're doing 2 to the x is, you don't know what 2 to the 1/2 is, and you can't write it down. Okay? And we talked about that last time. And you avoid zeros in the denominator. That's where things are undefined. Okay, well, so anyhow, here's composites, right? Now, we could write down a table of our basic functions. Right now, what are our basic functions? Well, we got x squared, we've got 2 to the x, we got 1 over x, we got 1 over x squared, right? Okay, and I'll just stick with these 4 for the moment, but you can add to them because the square root of x is a basic function, and I'll talk about it a little bit. Okay, so let's say that these are our functions f of x. Actually, let's let these be the f of x functions. Let this be the g of x function. Okay? So, if we do f of g of x, that's what we're going to put in here. Okay? Now, what are we going to put in here for f of g of x? Okay, if f of x is x squared, g of x is 2 to the x, then what is f of g of x? Well, f of x is x squared. So what's f of g of x? Yeah, this g of x squared, right? In other words, we've replaced x by g of x, right? We've got to replace this x by g of x. So all we've done is we just said, okay, now this x is now g of x, so this x had better be g of x, right? Any problem with that? Okay. And what is g of x? Well, it's 2 to the x. Okay. Now we get to what is 2 to the x squared. Well, you have a law of exponents that applies, so you want to stop and think about what your law of exponents. What law of exponents applies to this? If you're taking a power of a power, you multiply the powers. And we talked first day, I think, about why that is, so you might want to review that. So you multiply the power. You got the power x. You got 2 raised to the power x, and that's raised to the power 2. You multiply those powers. Okay? Reasons that you really need to work to understand. And of course, you just write that as 2 raised to the 2x. Now, right now, if you can just get from here to here and mess up the laws of exponents, I'm not going to worry seriously about it, although I'll, when I look at your homework, I'll make little notes. Hey, careful there. Okay? This part's good, this is good, but you messed this part up. Okay? Then we could write then here, and I'll write it the simple way. That's 2 to the x squared, which we really probably want to write 2 to the 2x, right? Okay? You understand why I put that there, right? Because f of x is x squared, g of x is 2 to the x, right? So here's your f of g of x. Okay? So if f of x is 2 to the x and g of x is 1 over x, then what's f of g of x? What's the first thing you want to write down? What's f of g of x? Just use this and this. Well, we've replaced x with g of x, haven't we? So what do we have to do over here? There's an x, we got to replace that with g of x, right? So this is 2 raised to the g of x. If f of x equals 2 to the x, then what's f of aardvark? 2 to the aardvark, right? So what's f of g of x? 2 to the g of x. Okay? The rule tells you this. Which is then 2, well, what's g of x? It's 1 over x, right? So it's 2 raised to the 1 over x. So we could put that expression here. So we're going to have 16, you've got 4 here, 4 here, that's going to give you 16 composite functions, right? So we're going to work on being able to fill in at least that table. And we could add square root of x out here and square root of x out here. We already figured out what f of g of x is if f of x is square root of x and g of x is 2 to the x, right? So that would give us over here our square root of 2 to the x. Okay? Now we could write that as 2 to the x over 2 if we wanted to, but we'll worry about that later. That gets into laws of exponents, and not everybody's familiar. So you need to be able to follow this process. Now there's more you want to be able to do with that, but just understanding that it's just a matter of whatever replaces x has to replace the x. Okay? So if g of x replaces x, then every x becomes g of x. Okay? And then you try to use the rules of exponents or whatever to write your function.